Hello students, myself Sumit Katheria. Today I am going to explain you the chapter Motion from CBSE 9th class Science. In this chapter, we will include the following topics which are motion, type of motion, physical quantities related to motion are scalar and vector quantities, distance and displacement, speed and velocity, uniform and non-uniform motion, acceleration. Further, we will include equations of uniformly accelerated motion, free fall, which means its motion under gravity, graphical representation of motion, equation of motion by graphical method, circular motion, and applications of the concepts in numericals and question answers. Now, I would like to explain you what is motion. The term motion means any object when covers a distance with passage of time, then the object is said to be in motion. In our daily life, we observe many of the objects which are continuously in motion, such as car, train, buses, aeroplane, any person. These all things or objects are performing movement, so we can say they are in motion. Even the small objects like or particle like atom and large objects like planets are also following motion. So we can say in a simple language, any object is said to be in motion if it covers a distance in a particular time period or with the passage of time. For example, if any object is at position A and it covers a distance and reaches to B, with the passage of time, this object has covered a particular distance. This is called as motion in the particle or object. Now we come to our next topic, that is types of motion. Students, there are following category of motion. First of all, rectilinear motion. Second is circular motion. Third is vibratory motion. And fourth is rotational motion. Here it has to be remembered this rectilinear motion is also known as straight line motion. Circular motion can be said as curvilinear motion. Vibratory motion is known as to and fro motion. And rotational motion is known as it is. Understand what is rectilinear motion or straight line motion. Students, it means when any object moves in a straight path, the motion is said to be a straight line motion or rectilinear motion. There are many more examples, such as if a car is moving on a straight path, if an athlete is running on a straight path, it is said to be a straight line motion. Now we understand what is curvilinear motion, or we can say as what is circular motion. Students, when any object travel in a circular path or curved path, the motion is said to be in a circular motion or a curvilinear motion. For example, a car moving in a curved path, or an athlete running along a curved path. The motion is said to be curvilinear motion or circular motion. Now we come to the third type, that is vibratory motion or to and fro motion. Students, when any object perform to and fro motion or perform oscillatory motion, the motion is said as vibratory motion. For examples, pendulum of clock or simple pendulum. Such as in diagram you can see the pendulum is oscillating from its mean position and performing a to and fro motion. Students, one thing which has to be remembered, it is in these three types of motion there was no change in orientation of the particle or object. Means there was no change in orientation of object or particles. So these three types of motion, is called as translational motion. Now the fourth and the last type of motion is rotational motion. Students, when any object spin on its axis is called the rotational motion. For example, the earth spin on its axis. Similarly, the fan, top, if you have noticed, they rotate on their axis. One thing has to be remembered, that in rotational motion there is change in orientation. So it is called as non-translational motion. Now we understand the physical quantities related to motion. First of all, we will understand scalar quantities and vector quantity. Students, scalar quantity means the quantities which are defined by their magnitude only but no direction. These quantities are called as scalar quantities. Quantities which are defined by only magnitude but no direction are called scalar quantity. For example, distance, speed, mass. Similarly, vector quantities are the quantities which have magnitude but also direction, or we can say quantities which are defined by magnitude as well as direction are vector quantities. For example, displacement, velocity, acceleration, and force. Now, the another quantities are distance and displacement. Now, we understand the another quantity, distance and displacement. Distance. Distance means it is the actual path traveled by any object or particle. We can understand it by any object at position A traveling a distance reaches to point B. The path traveled or the total path traveled by the object is known as distance. Now, displacement. Displacement is the shortest path between the initial and final position. Diagram, if we draw the shortest path between the final and initial position, this shortest route or this shortest path is called as displacement. The thing which has to be remembered that distance is a scalar quantity. Another thing, distance cannot be 0. Similarly, for displacement, it is a vector quantity. It can be 0 or negative. Distance. The SI unit of distance is meters. For displacement, it is same. The SI unit of displacement is meters. Now we understand the quantity speed and velocity. Speed. Speed of a body is defined as the distance travelled by the body in per unit time. in per unit time, or we can say the change in rate of distance is called speed. It can be expressed as time. Here v is speed, s is denoted by distance, and time is denoted by t. The SI unit of speed is meter per second. The SI unit of speed is meter per second, or we commonly use kilometer per hour. Speed is a scalar quantity because it is having only magnitude but no direction. If we talk about average speed, it is expressed as total distance upon total time. Now we understand velocity. It is defined as the displacement covered by the body per unit time. Students, velocity is a vector quantity because it have magnitude and direction. The SI unit of velocity is meter per second. Velocity can be 0 or negative. Students, if we talk about average velocity, we can say total distance, total displacement upon total time. If we go through the definition, we can express velocity as v is velocity, s is displacement, t is time. To show the direction, we have used arrow on these indications. How we understand uniform and non-uniform motion? First of all, uniform motion. Students, from the word we can understand when any object covers equal distance in equal time interval, the motion is said to be uniform motion. This can be understood by the following data. If we take time in seconds and distance in meters, then after every similar time interval, any object covers similar amount of distance, then the motion is said to be uniform motion. For the given data, if we draw the distance time graph, we will get a straight line. Say that for uniform motion, we will get a straight line for distance and time graph. Example, train running with a speed of 60 km per hour in each direction. So we can say that in uniform motion, the object always travels in a straight path or straight line. After uniform motion, now we understand non-uniform motion. In this, when any object covers unequal distance in equal time interval, this motion is said to be non-uniform motion. This can be understood by the given data. In the given data, we can understand that in equal time interval, the distance covered by the object is different. From this data, the distance time graph we obtain is a curved line. It means a non-uniform motion cannot obtain or give a straight line, but it always gives a curved line. For example, when brakes are applied on a car or an airplane running on a track to take off. After uniform and non-uniform motion, we now understand what is acceleration. In a simple language, we can say the rate of change of velocity of a moving object or body is said to be acceleration. Acceleration. This can be expressed as acceleration is equal to change in velocity upon time taken. What does the change in velocity means? Change in velocity means final velocity minus initial velocity. So the acceleration can be explained as final velocity minus initial velocity upon time taken. This formula can be explained or expressed as acceleration is equal to v minus u upon t. Here V is final velocity, U is initial velocity, T is time, and A is acceleration. Students, things to be remembered are: acceleration is vector quantity, its SI unit is meter per second square. Acceleration can be positive, negative, or zero. So students, till now we have covered the topic motion, which includes motion, types of motion. The types of motion are classified as, first of all, rectilinear motion, circular motion, vibratory motion, and rotational motion. After that, we studied about the quantities related to the term motion, that were scalar or vector quantity, distance or displacement, speed and velocity, uniform and non-uniform motion, and at last we studied about acceleration. So students, be very attentive and study very carefully the explained topic, because these topics are going to be the part of our further explanation, the topics which are going to be covered in the next video.